In grade 9, when we looked at number patterns, or we worked with number patterns, we worked with both those that had constant ratios and constant differences, where constant ratio was where you multiplied with the same number every time to get the next or the consecutive terms, and constant difference were the questions where you added or subtracted, so added or added a negative number every time to get your consecutive terms. In grade 10, however, we specifically only focus on those constant difference questions where you add every time. And we go a step further because we've now done straight lines, and we call these linear number patterns. So, in other words, if it has a constant difference, just like last year, we this year, and for sometimes still, we're going to be calling these linear number patterns. Linear, straight line has a similar form. So for straight line, we know it's y equal to mx plus c. Okay, where your variables are y and x. Now with a number pattern, any of them actually, Tn is like your y, it's your output value. And n is your x, your input value. Do you see there's something being multiplied with your input and then added? Okay, so there's a correlation between the constant difference, which we now call linear number patterns, and the straight line. In fact, this is actually an application of the straight line. So here, do you see that both of these, if you go look, and it's good form, but not necessarily like the end of the world if you don't do it, but usually we start by saying this is term 1, term 2, term 3, term 4, term 5. So in other words, your input is 1, n is 1, then t1 is 3. If your n is 2, then your t2 is 7, and so forth. And if we look at these 5 terms over here, you'll see every time from 3 to 7, we are adding 4. Similarly, from 7 to 11, we are adding 4, and so forth. So over here, we have a constant difference of 4. So our terms are increasing. Similarly, here, if we go label them also, you'll see however the numbers are getting smaller by 5. So our constant difference is minus 5. Not 5, minus 5. Okay, and another way you can get that always is saying term 2 to minus term 1. So for this one, it would be 7 minus 3. So it's 4. And for this one, term 2 minus term 1 would be 20 minus 25 would be negative 5. So your constant difference is what you are adding every time, even if that is a negative number. Okay. For to be constant, though, you need to check more than just one. You can't just see, okay, from term 1 to term 2, we're adding 4. So that's our pattern. You need to just check. There's a reason we give you more information. Unless, of course, we tell you it's a linear number pattern, then you can assume whatever that difference is between the first two terms needs to continue. So let's look at our formulas. I'm not entirely sure how you would have been taught up until now. It very much depends on the teacher, whether they take you straight from grade 8 or 9 to this formula, which is the one that will be on your formula sheet, which you get in November exams and then the whole of matric. So this is the formula that's on the formula sheet, but this is another way of finding it. Okay, so we're going to be working with both in this video. So the one way is you can take your first term, you plus n minus 1 stays n minus 1 because your formula is in terms of n. Okay, so the n does not change, don't substitute anything in there. And then you multiply that, so times d, right? Distributive property where you have to multiply d with each term. And that's what you would have to do to get to your formula. So just for interest's sake, let's quickly do it with this one. This would be plus dn minus d. So in other words, you have dn plus A minus D. And that's your constant term. In this one, we just say dn, which is, it's always your constant difference, will always be multiplied with n. And then plus c, we see is some constant. And it works out that way that your first term, whatever your first term is, would always be your constant difference plus c. So in other words, if a is your first term, then if you want c on its own, you're going to go minus d. So c would be a minus d, which is what we also had here. That's one way you can find it, but it's not necessary. You can, there's easier ways. You can use the second formula. We're gonna do it when we get to the examples. Also, please note, n is a placeholder for the term number or whichever position in the sequence. Sequence is a fancy word for num pattern, but unless otherwise stated, and we'll get to when that is, if they give you what the last term is, basically. Otherwise, we see it as in the number of terms being infinite. So if I look at this question, do you see the dot 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 there? That means we have an infinite amount of terms. It doesn't stop anywhere, it just dot 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 continues. Now, if we look at these 5 terms, every time we are adding 4. It's the same question as we had here, or the same term number, no, it's the same number pattern as we had there previously. So every time we are adding 4, we've already calculated that. It's asking us to find the general or the nth term. They will not necessarily give you the slash with the 2 options. You need to know general term, nth term, Tn. All of those mean you need to find the formula. The formula where it's going to be one of 2 ways, and we're still going to do it both ways. Let's start with the formula that's given. Tn is a plus n minus 1 times d. So a is your first term. Your first term here was 3. Plus n minus 1 stays what it was, and you are timesing with your constant difference, which is 4. Then you're going to have to multiply this 4 with each term inside of the brackets. So you're going to get 3 plus 4n minus 4. It's 4n, you add your like term, so it's minus 1. And then that is your formula. Tn is equal to 4n minus 1. That's the one way. The other way is you straight away know it's going to be 4n. It's d times d, constant difference, times n. And then you ask yourself, okay, so term 1 is equal to 3, right? But if you use this formula, you will have 4 times 1, which is 4, and you want 3. So you ask yourself, how do I get from 4, how do you get from your constant difference to that first term? And that is u minus 1. And it really doesn't matter if you use this whole story or if you just write the answer, because it's 2 marks either way. It's 1 mark there, 1 mark there. Even if you use this, 1 mark there, 1 mark there. Then finding the 20th term. In other words, what they're telling you is n is 20. So they're asking you to find T20. So everywhere here you had an n, you replace it with a 20. Just please note, okay, it wasn't done as nicely by me here, but the n is a subscript. So if you have your 2 lines like this, it must be T, and n must be like hovering a little bit between the 2 lines. Okay, so you multiply the 4 and the 20, and you minus 1, and then you get your answer, which is 79. So term 20's value, its Tn, would be 79. And then similarly, which term in the number pattern or sequence, here I'm using both words because they could use either, is equal to that number. So they gave you not the n, they gave you Tn is 399, and they are asking you what n, which term number, which term. So you go put that value in Tn's place on this side of the equation, and you have to solve for n, which if you go and look here, you want n on its own. Currently happening here is a times 4 and then a minus 1. You have to work inversely. So you are first going to plus 1 and then divide by 4. And you get your answer of 100. So term 100 will have the answer 399. And if you want to, but it's not necessary, you can say T100 is equal to 399, but that's the important part, is that you calculated in to be 100. This question is the same as also what we had here right in front. It's that same question, so we already know we're minusing 5 every time. So if you want to use the formula, please remember this correctly. People often forget this plus there. That's one of the biggest mistakes I regularly see. Okay, so A is your first term, which is 25, plus A minus 1 stays, and you are multiplying with -5. I specifically put the multiply sign there because otherwise we get confused and we forget that that -5 needs to be multiplied into the bracket. That's also like a common mistake that we see. Okay, you multiply the -5 into the bracket. Okay, so you're going to get 25. N times -5 is -5n, and -1 times -1 is +5, not -6. It's multiplication, please. And then you know it's -5n, and the 25 plus the 5 is 30. That's the one way. Alternatively, you know it's going to start with -5n because that's your constant difference. Then term 1 is 25. But if you go substitute in -5 times 1, then you're going to get -5, but it should be 25. So you ask yourself, how do you get from -5 to 25? And the way you do that is to get from -5 to 0, you add 5 and then another 25. So you are adding 30. So that's how you can do it with an inspection. And either way is correct. This question asking for the 15th term. So they're telling you n is equal to 15 and they are asking for Tn. So you substitute 15 everywhere there was an n, which is here as well as here. And then you put it in your calculator or you do the calculations whatever way you want to, and you get an answer of -45. And then this last question over here, which term in the number pattern is equal to -220? So in other words, they are telling you the answer is -220 and they are asking for n. So you're going to put this -220 in Tn's place and solve for n. And then you go look here. Over here we are multiplying with -5 and then we are adding 30. So we're going to do the inverse, which is first subtract 30 and then divide by -5. And then you'll get an answer of 50. So term 50 is equal to -220. So again, if you would like to, you can say term 50 is equal to -220, but the important part is that one over there. In the next video, we're going to be looking at linear number patterns with unknown variable terms. And then in future video, we will also look at an application of the linear number pattern, which is